This is the Lesson 8 activity for college algebra. A complex number is a number of the form a plus bi, where a and b are real numbers, and then the I is the imaginary number that represents the square root of -1. So for example, 2 plus 5i, the real part is 2, and the imaginary part is the 5i. So we got several examples here. How do we do arithmetic with the complex numbers? It's different than anything we've done before. We've only ever worked with real numbers. Okay, so we can still add, subtract, and multiply complex numbers much the same way we do when we have algebraic expressions. So you can think of the I kind of like an x, but then just remember that anytime you see an I squared, replace it with a -1. So 2 plus 3i times 1 plus 5i, we are going to add these together by combining like terms. So 2 and 1 are like terms, and I get 3. And then 3i plus 5i combine to make 8i. Part B, 2 plus 3i minus 1 plus 5i. When you subtract two algebraic expressions, you distribute the negative. So I have 2 plus 3i minus 1 minus 5i, then combine like terms. So 2 minus 1 is 1, 3i minus 5i is -2i. Multiplying complex numbers is like multiplying two binomials. We're going to use FOIL or lobster claw or the distributive property, however you've learned this. So first, I have 2 times 1, so that's 2. Outer is going to be 2 times 5i is plus 10i. Inner is plus 3i. And last is going to be plus 15i squared. Then we combine like terms. So I have 2 plus 13i. And then instead of 15i squared, I'm going to replace that I squared with a -1. So instead of 15 times I squared, it's 15 times -1. So this is 2 plus 13i minus 15, and I have some more like terms now. 2 minus 15 is -13. And part D, I'm just going to do the same process again, multiplying two complex numbers, and I'm going to do first, outer, inner, last. So first, 2 times 2 is 4. Outer, 2 times -3i is -6i. Inner is 3i times 2, which is positive 6i. And then last, -3i times 3i, which is -9i squared. Then I combine like terms. So these middle terms here, I have a -6i and a plus 6i, a positive and a negative, same amount, they add to 0. So this becomes 4 minus 9i squared. And let's replace that I squared with a -1. So this becomes 4 minus -9, which is 4 plus 9, which is 13. Something special happened in that last example, the 2 plus 3i times 2 minus 3i. We got a real number. The answer was 13. There were no i's. Okay, that happened because 2 plus 3i and 2 minus 3i are called conjugates of each other. So the conjugate of a plus bi is a minus bi, and vice versa. So for example, the conjugate of 3 plus 5i is 3 minus 5i. And then if I want to multiply them together, first, outer, inner, last. So 3 times 3 is 9, minus 15i plus 15i minus 25i squared. These cancel, and I get 9 minus 25 times -1, which is 9 plus 25, which is 34. So it will be helpful to have a shortcut for multiplying two conjugates together. Let's multiply a plus bi times a minus bi. So when I do FOIL, I'm going to have a squared minus abi plus abi minus bi squared, and the middle two terms cancel, and this is going to be a squared minus, that should be b squared I squared, minus b squared times -1, which is a squared plus b squared. Okay, now let's practice solving some quadratic equations. 2x squared equals negative 6x minus 7. Typically, when you have a quadratic equation, you want one side to be 0. So this is going to be 2x squared plus 6x plus 7 equals 0. And when I solve using the quadratic formula, I get negative 6 plus or minus the square root of b squared, which is 36, minus 4 times a times c, all over 2a. So negative 6 plus or minus the square root of 36 minus 4 times 2 times 7 is 56, all over 4. So this is negative 6 plus or minus the square root of negative 20 all over 4. Negative 20 can be reduced. We did it earlier in the lesson, and we got 2i root 5. So this is negative 6 plus or minus 2i root 5 over 4. Break it into two fractions, and we have negative 6 over 4 plus or minus 2i root 5 over 4. And then simplify each fraction. So I have negative 3 halves plus I root 5 over 2. For part B, first I need to distribute that 2, and then I need to move everything to the left. So this is going to end up being x squared. 2 times 2x is 4x, and I'm going to subtract it from both sides, so I have minus 4x. And then 2 times 1 is negative 1, and I'm going to add that to both sides, so I get, 2 times negative 1 is negative 2. Add that to both sides, and 10 plus 2 is 12. Try to factor it. It won't work. There are no two numbers that can multiply to positive 12, but add to negative 4. So we use the quadratic formula. So I have x is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is going to be 4 plus or minus the square root of 16 minus 48, which is negative 32, all over 2. And then 32 is a multiple of 16. So 16 goes into 32, so I'm going to use that to simplify. So I'm going to rewrite this as 4 plus or minus the square root of negative 1 times 16 times 2 all over 2. Square root what you can square root. So this is 4 plus or minus I times 4 times root 2 all over 2. Break it into two fractions. 4 over 2 plus or minus 4i root 2 over 2, and reduce each fraction. 2 plus or minus 2i root 2. The kinds of answers you get from the quadratic formula depend only on what happens inside the radical, right? So if what's in that radical comes out negative, you are going to have imaginary solutions. And if it's positive, you're going to have real solutions. If it's 0, you're going to have one real solution. Okay, so let's look at this. So my equation is x cubed plus 3x equals 0. Graphically, it looks like I have two solutions. Touch the x-axis twice. Two solutions, one at negative 3 and one at 0. If I were to apply the quadratic formula, I would have x equals negative b plus or minus the square root of b squared minus 4 times a times c. C is 0 because there's no constant term, all over 2a. Simplifying, 4 times 1 times 0 is just 0. So this is negative 3 plus or minus 3 all over 2. Okay, so if I do the plus, negative 3 plus 3 is 0. 0 over 2 is 0. When I do the minus, I get negative 3 minus 3, which is negative 6, over 2 is negative 3. So my algebraic solutions match my graphical solutions. And the discriminant was 9. The number under the radical was, I'll write it out, 9 minus 4 times 1 times 0, which is 9 minus 0, which is 9. Okay. So our conclusion about this type of problem is that when the discriminant is positive, right, it was 9, when the number under the radical was positive, the quadratic equation has two real number solutions, and the graph looks like this, two x-intercepts. So here's an example where you have only one x-intercept. Looks like there's only one solution, and it happens at negative 1.5. Let's see if we get negative 1.5 using the quadratic formula. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's negative 12. And then do a little calculation here. 4 times 4 times 9 is 144. So I get plus or minus 0 over 8. And negative 12 plus 0 and negative 12 minus 0, those are both just negative 12. So 12 over 8, that reduces to 3/2 or 1.5. And then the discriminant was the b squared minus 4 times a times c. That came out to 144 minus 144, 0. The number under the radical is 0. And because it was 0, I only had one solution. So our conclusion is that when the discriminant is 0, the quadratic equation has one real solution and the graph has one x-intercept. Okay, our last situation is when the parabola sits entirely above the x-axis. There are no real solutions. So real solutions, NA. It doesn't cross the x-axis. There aren't any. But what happens when we use the quadratic formula is that we're going to have x equals negative b. B in this case is 0, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So this is the square root of negative 4 over 2, which is 2i over 2, which is I. There's our solution. It's not a real solution, it's an imaginary solution. And the discriminant was 0 squared minus 4 times 1, which was negative 4. So that is what caused our result to have an I in it, right? I had to take the square root of a negative. That's going to lead to an I. So if the discriminant, the number under the radical, is negative, then the quadratic equation has no real solutions and the graph has no x-intercepts. In conclusion, the discriminant can tell you how many and what kind of solutions there are to your quadratic equation. Two unequal solutions that are real numbers. If a, b, and c are rational numbers and the discriminant is a perfect square, then the solutions are rational. And if the discriminant is not a perfect square, then the solutions are irrational. So these are two subcases of when you have two real solutions. They could be rational, they could be irrational. You might have just one solution that is a real number, or you could have no real solutions. Okay, a couple of optional extra practice problems. We'll go through these quickly. Quadratics, you want one side to be 0. Oops. So I'm going to add 15 to both sides, and I have 0. I'm going to use the quadratic formula. So x is negative 8 plus or minus the square root of b squared, which is 64, minus 4 times 15, all over 2a. So I have negative 8 plus or minus the square root of 64 minus 4 times 15 is 120. I'm sorry, it's 240. 4 times 4 times 15 is 240. And I'm going to do 64 minus that. 64 minus 240 is negative 176 all over 8. Then I have to see if negative 176 has any perfect square factors. And after a quick check on the calculator, it does. 16 goes into 176 11 times. So it's going to be negative 8 plus or minus the square root of negative 1 times 16 times 11 all over 8. So this is negative 8 plus or minus 4i root 11 over 8. And then we could break it into two fractions and reduce at the same time. So negative 8 over 8 is negative 1. 4 over 8 is a half, so this is going to be I root 11 over 2. Part B, same thing. Just use the quadratic formula. The opposite of b plus or minus the square root of b squared, and 15 squared is 225. Minus 4 times a times c all over 2a. So I grab my calculator and I say, okay, well, 4 times 54 is 216. And 225 minus 216 is 9. So I have x equals 15 plus or minus the square root of 9 over 2. Square root of 9 is 3, so this is 15 plus or minus 3 over 2. 15 plus 3 is 18. 18 over 2 is 9. And 15 minus 3 is 12. 12 over 2 is 6. Two solutions, 9 and 6.